Right, welcome to the question that has to do with binomial expansion. So I asked to look for the term independent of y. This y is for this, a is for this, x is for 2 in the binomial expansion below respectively. Now I want you to note that another way this question can be asked is find the constant term in the binomial expansion. When they say something is independent of x, it means x to the power of 0. And for instance, I'm writing 4x, this is dependent on x. But if it's not dependent on x, then it's x to the power of 0, which is the same thing as 4, which is a constant. Yeah, so because x to the power of 0 is 1, 1 times 4 is equal 4. All right, so right away, we're going to be solving, and I want you to take note of what I will be saying. Okay, assuming we have t to the power of t base r plus 1 equal n combination r. I'm going to solve. Now, binomial expansion, I'm going to explain it further in the nearest future. This value 3y, I want you to pay attention. This value 3y, I'm going to write it here. Now 3y to the power of this 8 minus r, and the value here 2 over y raised to the power of r. Now we should note that where r plus 1, this r plus 1 term is independent of y. If we're using x, it will be of x. Okay, so it means that y to the power of 0 equal 1. That I have explained it. So it means this is independent of y. I just want you to note that. Now the next thing is for us to expand this, not per se expanding it, but isolating y, and we need the law of indices to do that. So I'm going to be having n combination r. Please follow me. This 3 to the power of 8 minus r. Remember, I want to isolate y to the power of 8 minus r. This law of indices, the power law. So it's this 3 can go take 8 minus r, and then this y. It's just like having let's say 3y to the power of 2. The answer will be 9y squared. Now it's 3 square 9, y square y square. So that's the same law that applies to this. Okay, for this, all right, 2 to the power of r, y minus 1 to the power of r. Also note that 1 over y is the same thing as y raised to 1 minus 1. I believe you following. Okay, so don't need this. Okay, so I'm going to pick n combination r, 3 raised to the power 8 minus r, 2 to the power of r. As you can see, I'm taking away the constant. Now I'm left with y to the power of 8 minus r times y to the power of minus r. I know in multiplication it means addition. So this is what we'll be having. N combination r, 3 to the power of 8 minus r to the power of r, y, 8 minus r minus r. Because plus minus is what? Minus. So uh, n combination r, 3 to the power of 8 minus r, 2 to the power of r, y, 8 minus 2r. Now, you can see that y has been isolated. Now, since we've defined that r plus 1 term is independent, that means y equals 0. So we're going to be picking this y to the power of 8 minus 2r equal y, because it is independent. We're looking for the independent value. So looking at this and then comparing, we can say 8 minus 2r equal 0. If 8 minus 2r equals 0, the question is, what is r? This comes 8 equal 2r over 2 over 2, 2 here 1, 2 here 4. It means that r equal 4. You now substitute the value for r equal 4 in this. So n is actually the power, which is 8. So we're having 8 combination 4, 3 to the power of 8 minus 4, 2 to the power of 4. There is no need for this because we already know that it's going to give us 0. That is y to the power of 0, which is 1. So we're going to just simplify this. To simplify this 8 factorial over 8 minus 4 factorial, 4 factorial times 3 to the power of 4 times 2 to the power of 4. So 8 factorial over 4 factorial, 4 factorial times 81 times 16. So we're having 8 times 7 times 6 times 5 times 4 factorial. I'll stop at 4 factorial. Over 4 factorial times 4 times 2 times 1. Sorry. Times 4 times 3 times 2 times 1 times 81 times 16. So 4 factorial cancels 4 factorial. 4 factorial and 2. 4 times 2, 8. Cancel this. 3 in itself 1, 3 here 2. So 7 times 2 times 5 times 81 times 16 will give us 90,720. So that's all for this question. I'm going to go to the next question. I've explained this very, very, very well. So in this and this and this, I'll be jumping some steps. Right, skipping all this, I'll just go straight to the point for the next question. N combination r, this a to the power of 2, all right, a to the power of 2, and the power here is 9 minus r. The next value is minus 2 over a to the power of r. So I'm going to expand this. All right, let me just expand it. I have n combination r, a to the power of 2 times 9, 18, minus 2 times minus r, minus 2r, times negative 2 to the power of r, times 1 over a to the power of r. You see, I've splitted this. So the next step is I'm going to pick everything that contains a, and it will look like this. So it's going to look like this. I've kept minus 2 here, so that's what I'm having. And this will now give us minus 18 minus 2r minus r. So this is how it's going to look like. Now, since we're looking for the independent term of a, it means a equal a raised to the power of 0. So we're having a to the power of 18 minus 3r equal a to the power of 0. So we're having 18 minus 3r equal 0. Looking for r, therefore r equals 6. Now I'm going to substitute the value of 6 inside the last equation we wrote apart for a, because we know a to the power of 0 and to the power of 0 means 1. So this is what's going to have as our final answer. Right, so this is what we're going to be having 9 from the initial value, and then we just simplify this and to give us this. Right, so this is what we're having for that question. All right, to the next one. For the next one, skipping all those notes, say combination r, I'm having 3x squared to the power of 15 minus r, and then I'm having minus 1 over 3x to the power of r. So I will be expanding this and isolating x, and it's going to look like this. Right, I know there's a lot. So when you expand this, this is what you're supposed to get. Now since it's independent, it means x to the power of 30 minus 3r equal x to the power of 0. Therefore 30 minus 3r equal 0. Therefore r equal 10. Now I'm going to substitute the value for 10 in this, and it's going to look like this. So it's going to look like this. So 15 factorial is 15 times 14 times 13 times 12 times 11 times 10 factorial. I'm going to stop there. This 5 times 4 times 3 times 2 times 1 times 10 factorial times 3 to the power of 5 times 1 over 3 to the power of 10. Alright, I'm going to simplify it and write the final answer. Out here, I haven't solved everything. We're left with 101 over 31. Okay, so to the last question. All right, so we're looking for the term independent of x, or we're looking for the constant term. I've written this for more clarity. So we're having n combination r. This value here, 2x to the power of 8 minus r multiplied by minus 3 over x r, right? So we're going to be expanding this. This will give us n combination r, 2 to the power of 8 minus r, x to the power of 8 minus r, minus 3 to the power of r, x to the power of minus r. Law of indices. So I'm going to pick all those that are not x, 8 minus r, minus 3r, and then back to the guys with x now, minus r. So what I'm having is n combination r to the power of 8 minus r times minus 3 to the power of r, x to the power of 8 minus 2r. Since x is independent or a constant, uh-huh. So 0 equal 8 minus 2r. Therefore, r equal 4. I'll substitute the value for 4 here and get my final answer. So this n is this 8 here. So 8 combination 4. 2 to the power of 8 minus 4 minus 3 to the power of 4. When negative values raise an even number, that value becomes even positive. All right, so this will be the final answer. Thank you very much. Please like, share, and then subscribe.